I'm going to talk about linear inequalities. I'll assume that you know the basics of linear equations, all right, including what a linear equation is. If you don't, I would invite you to watch the necessary videos, all right? So let me continue. So you can think of a linear inequality as what you get when you replace the equal sign in a linear equation with an inequality symbol. All right, so for example, x minus y is greater than 1. So x minus y equals 1 is a linear equation. If I replace the equals with the greater than symbol, then I get the linear inequality that I just wrote on the board. All right, so let's think about what it would mean to find a solution to this linear inequality. So x and y are separate variables, so we apparently have to find pairs of values such that the difference in the x and y values is greater than 1, right? Now I'm going to write a solution using the compact parenthesis-based notation that is used for linear equations, okay? So how about 3 comma 1? Can you see that if x was equal to 3 and y was equal to 1, that x minus y would be 2, which is greater than 1? So that point, that pair of coordinates, is a solution to this linear inequality. And we can, of course, find other solutions, 4 comma 2, 5 comma 3, all right, and so on, as well as minus 1 comma minus 3, minus 2 comma minus 4, minus 3 comma minus 5, and so on. All right, for all of these points, find the difference between the 2 points. Subtract the second point from the first, and you'll see that you always get a number that's greater than 1. You may recall that when we plotted the solutions to a linear equation, all the points on an xy coordinate plane, they made a line. Okay, that's not going to be true for a linear inequality. Okay, it's good. The points are going to populate a region, but it's going to be more than just a line. All right. So let's do another example. Suppose we had this linear inequality. Suppose we wanted to know what points in the following set are solutions to that linear inequality. 1 comma 2, 0 comma minus 4, 5 comma 16, and minus 4 comma minus 18. All right, so pause the video and try to answer that question now if you like. All right, so I'll go ahead and do it myself as well. So you could simply replace the x and y variables with the necessary corresponding values for each point, okay? And that would be fine. That'll get you the correct answer. Allow me to show you a slightly easier way. Let me first simplify the original linear inequality and move some terms around. So let me divide everything by 3. So that'll give 4x minus y is less than or equal to 3. Now let me move the y to the other side by adding y to both sides. And let me subtract 3 from both sides to move the 3 to the other side. All right, so we get some cancellation. So what do we end up with? We end up with y is greater than or equal to 4x minus 3. Now, strictly speaking, doing that, modifying the original linear inequality like that wasn't necessary, but it might be easier to work with. Okay, now you have to evaluate 4x minus 3 for every point rather than 12x minus 3y. And you need to see if it's less than or equal to y. So let me evaluate 4x minus 3 with respect to each of the 4 points. So 4 times 1 minus 3, that gives 1. 4 times 0 minus 3, that gives minus 3. 4 times 5 minus 3, that gives 17. 4 times minus 4 minus 3, that gives minus 16 minus 3, which is minus 19. All right, now let's see if what the right sides of each of those equations is less than or equal to the corresponding y value. So we have 1 minus 3, 17, and minus 19. Is 1 less than or equal to 2? Yes. Okay, so the first point is a solution. Is minus 3 less than or equal to negative 4? No, it is not. Is 17 less than or equal to 16? No, it is not. Is minus 19 less than or equal to minus 18? Yes, it is. So the two solutions are 1, 2 and minus 4, minus 18. All right, so that set of points. Now, I'd like you to do one more exercise. Would you please determine what elements of a set of points are a solution to this linear inequality? 1/2 x plus 1/4 y is greater than 4. And the set of points is the following: 4, 8, minus 1, 17, 5, 5, and 10, minus 3. All right, so pause the video and do that now, please, if you like. Okay, so I'll go ahead and work it out as well. And so as before, I will first simplify the original linear inequality, even though it's not strictly necessary. This time I'm going to multiply everything by 4. So that'll give me 2x plus y is greater than 16. And let me subtract 2x from both sides. So y is greater than 16 minus 2x. So let me evaluate 16 minus 2x with respect to all 4 points. So 16 minus 2 times 4 gives 8. 16 minus 2 times minus 1 gives 18. 16 minus 2 times 5 gives 6. 16 minus 2 times 10 gives minus 4. All right, so now let's see if those 4 results, 8, 18, 6, and minus 4, are less than the corresponding y values. Is 8 less than 8? No, it is not. Is 18 less than 17? No, it is not. Is 6 less than 5? No, it is not. Is minus 4 less than minus 3? Yes, it is. So the only solution is 10, minus 3.